So there's a warm up. Write it down. Give it a try.
Okay. Chain rule.
Wait, it's being recorded. Oh, okay.
Differentiation. Implicit differentiation. I feel like I don't think right now, but I think later in the lesson. Sort of respects that.
I think they're getting the chain rule down.
And a quick comment. Pretty soon they're going to have to lock in who is signed up for the test and who is not. There are 8 of you in here who have not signed up for the test.
Okay, I will.
If you want to, I don't mean to pressure anybody, but it's free because the county's paying for it, so you might as well.
I'll register for all my tests. In fact.
Okay. You guys don't need laptops out? Miriam? How do we do these problems?
The first one, I did the parallel tennis.
What's on the other side of the equal sign?
So
What do I write here?
y prime over dy over dx.
dy dx. What about the second one?
The second one, I did the chain rule. So first I did the derivative of sine, which is cosine, and then I put the stuff in the parentheses, so theta squared, and then I did the derivative of theta squared, and I got 2 theta. And then the 2 different.
Okay, but what is on the other side of the equal sign?
R.
R.
Oh yeah, R is.
It's not r. We've done the derivative. It's not r. What is it?
Prime.
R over d theta.
dr over d theta, which is better than r prime.
dr d theta, okay.
So the making a big deal about what's on the other side of the equal sign, because you're going to tell me in about 5 minutes, where did this come from? Why in the world did you do that? And I will point to this and say, well, the derivative of y, the way you wrote that isn't y prime, you wrote it as dy dx. How is y changing as x changed? Because what we're doing now is a thing called implicit differentiation. But why is this here? We don't want to do that. Implicit differentiation.
Okay.
So implicit differentiation is when there's more than one equation implied. You ready? Just so fun. Okay. All right, so here we have this equation, x squared plus y squared equals 9. What does that shape look like?
That's a circle.
Centered at
0.
0, 0, and the radius is?
3.
So is a circle a function? Does it pass the vertical line test? No. but it's an equation, it's a thing that we know, and I can have lines that are tangent to it that have slopes, right? So I wanna know what's the slope of the tangent line at x equals 2. All right, so here we go. We're gonna take this function. What's the derivative of x squared, Alex, when we do the derivative with respect to x?
Oh, 2x.
Multiply by the power, lower the power. And then technically we were doing, how does x change with respect to x? And I'll write this once. So really what we were doing is, how does x change as x is changing? Well, that's a 1, right? That's the reason we've never written it before. Well, how would we do power rule with the y squared?
Yeah, also here.
Yeah, okay. So it would be multiply by the power, lower the power. And then, Preston, what's the derivative of y with respect to x?
dy over dx.
dy over dx. This is what implicit differentiation is I have the x's and y's mingled together and they're now being a pain in the butt. Massimo, what's the derivative of 9?
0.
0. Okay, so again, that's 1. So I'm not gonna ever write that again. I wanna find the slope. Annie, do I have slope hidden in here somewhere that I need to get alone?
Yeah, you can write it as,
What do I need to solve for?
you just solve for y. Y equals.
To find the slope, what's the equation, what is, get it?
dy dx.
dy dx. So I'm gonna subtract 2x to the other side. And divide by 2y. So I get the slope is negative x over y. Reasonable? So the slope in a circle depends on the x and y coordinate.
But
Yep.
here's the problem. I simply use the algebraic expressions. I simply put x squared to the other side, then factored it out.
Factored it, then you got 3 minus x and 3 plus x.
Yeah.
Why does that help us finding the slope?
Let's find the derivative.
It doesn't help us find the derivative, so that didn't help us in this particular problem. Okay, but I want to find the slope of the tangent line at x equals 2. To find the slope at x equals 2, I need the y value. Luke, how am I going to find the y value?
Plug 2 into the original equation.
Okay, so the original equation. Y squared equals 5. What does that mean, y equals? If y squared equals 5, what is y?
Positive, negative root 5.
Plus or minus root 5. When you put the square root in, you need to remember plus or minus. Okay, so let's answer the question. I want to find dy dx for the coordinate 2 root 5, and I want to find dy dx for 2 negative root 5. So are you plugging in? What do I get?
You get negative 2 over root 5.
And welcome to calculus. You do not need to rationalize. Really. And this one, it's negative 2 over negative root 5. Yeah. Oh. All right. So let's look at it. Here's my circle, and at the coordinate 2, square root of 5, right there. Negative slope, looks like it's almost 1, 2 over root 5 is about 1. And then at the coordinate 2, negative root 5, it was a positive slope, also about 1. Like, made sense? It worked. And we got 2 answers. That's the problem with implicitly defined, is there's equations like sideways parabolas and hyperbolas and things that you could have slopes on. Yeah.
So how do you know what you did? Is it when the x and y are at the same time?
Well, it's when x and y are mixed together.
Okay.
Whether it's y squared or y cubed, the sine of x times y. It'll be obvious. You'll try to get y by itself and you'll be like, dang, that doesn't work. Okay, we just did this. So here's the steps of implicit differentiation. So differentiate everything with respect to x. With respect to x, which is why I made a big deal when Miriam did the warm-up. It was like, not y prime, dy dx, dr d theta. So do the derivative of everything with respect to x, and then it's algebra. Move all dy dx's to one side, and everybody else on the other side, factor out that dy dx, and then solve. Okay, so here we have a sideways parabola. So the question right now, when you see the y squared, in trouble. So write it down and give it a try and compare to the person next to you if you get stuck.
Oh, no.
What's the question?
How to isolate one. Why would you want that?
Don't know, it just came up as like I forget, like something about implicit differentiation.
Like, why would we do implicit?
Why would you want dy on its own? Like,
Oh, it's not dy on its own, it's dy dx.
yeah,
And actually, when we do differentials, there will be a dy on its own.
yeah.
But that's what he was talking about, was the dy on its own.
Here it's not.
Yeah.
But like in manufacturing, when you're like, oh, we're gonna create these and we have this tolerance, we can make the ball bearings of this piece
Yeah.
within this change in radius, and it'll still be okay. But if the radius changes too much, then the volume's gonna change too much, and then it's not gonna fit in the thing. Like, so there's a DVDR, and like, you'll be like, the volume's gotta fit,
Alright.
or you're gonna like blow up the station.
Yeah. Okay. So once you do it.
It happened.
Okay, what?
Hadley, the derivative of 3y squared, 6y. So multiply by the power, lower the power, and then multiply by the derivative of the stuff inside, dy dx. Claire, the derivative of 2y. 2, and then the derivative of y with respect to x is dy dx. Brooke, the derivative of 5x with respect to x.
dx.
And 5 dx dx, and I'm not gonna write the dx dx, I'm gonna be a rebel. Sydney, what now?
Now you can factor out the dy dx. So then it would be 6y plus 2. And then you can divide 6y plus 2 on both sides.
Found it. So here, the slope didn't depend on x at all. The slope depended on what the y value was. If the y value was positive, it did this. If the y value was negative, it did that. Yeah? And basically, we learned implicit differentiation today because I needed to do all the proofs of all the other patterns tomorrow. Those of you who've gotten far enough in the AP practice question, they are asking you to do the derivative of e to the x, and it says it's a calculator problem. We're gonna learn how to do this by hand tomorrow, which those of you that already looked it up, what is the derivative of e to the x? E to the x, it is its own grandpa. But either way, they wanted you to evaluate it at like 2 or 3 or something. You needed a decimal. So it's asking you to use your calculator. And the chapter 3 test, there is a calculator test and a non-calculator test. And the kinds of things that you need to do it for is, what is e to the 3? I don't know. Get the decimal. All right. Next adventure. Okay, Amir. It's all good.
Am I supposed to apply dy dx only to the y values?
We're doing the derivative of everything with respect to x.
I don't.
Okay, so Amir, derivative of x to the 4th. What was it?
4x to the power.
And then really we were doing dx dx, which is just 1. So we're gonna not write that down.
Let's see if I can still do it.
The derivative of x is supposed to, oh my god.
But this next piece is a product. Product rule gives us 2 pieces. Yes, Gus does the requisite eye roll.
Okay, that one's sweet.
Jasper? How we?
You will do x squared times y plus.
Hold on, implicit differentiation and the derivative of the y. that's first times the derivative of the second, plus second times the derivative of the first.
So, y squared times.
All right, what was your question?
I was gonna ask if we can just like, if we can write the x squared, y squared as xy, and then squared, and then do chain rule. So just do like
Oh,
x,
you
y
don't
in
wanna do that,
parentheses, and then
that's not gonna help,
it's not,
no, it'll make it more of a mess.
okay.
There's one thing you could do that,
Pretty hard. Yeah.
okay, Lily, what's the derivative of negative y squared?
-2.
And then the implicit part,
Oh, dx over
dy
dy.
dx. Okay, first of all, if you guys forget to do the implicit differentiation, you don't get the dy dx, you have nothing to solve for. Like, you've forgotten to put in the thing that you're looking for, that you're calculating. And another thing on these questions, after you get used to them, the thing you're gonna do wrong is if there's a constant over here, you're not gonna make it a 0. You're like, equals 9. The derivative of 9, you're gonna leave it as 9. So just putting that out there. Wow, where'd it go? Where'd it go? Sasha, what now?
You like move the x is over to the other side. So then factor out dy dx.
Okay, so I'm gonna leave these on the left and move the other guys over? Okay. So minus 4x cubed and minus 2xy squared. And Sasha says, well, factor out the dy dx. Okay, what now?
Sorry, I wanna have a look at. Choose. Oh, then you divide both times by 2x squared y.
It's a mess.
Yep.
So, depending on if you move things left or right, and if you simplified or not, you might have gotten so some of you got 3 negatives, like negative x cubed minus xy squared over x squared y minus y. Some of you might have gotten the positive.
What happened to the 2?
Does 2 over 2 reduce to
No,
1?
no, what happened to 4x? Negative.
Oh, okay, so I dropped it 2.
Okay.
Calm down.
What happened?
Are the blue one on the top and the blue one on the bottom the same?
6.
If I multiply by -1 over -1, that negative drops, and these guys switch
Kind of
sides.
works, so you're so good with like inflation rate.
However,
This worked.
here's the big question. What is the slope? Evaluated here. So what is dy dx at root 2 over 2, root 2 over 2? Without a calculator, figure it out.
2 over again. Just write the ones. Unless x cubed is cube part. Yeah, that's fair.
Is like why is two x subtracted out? Did it write x attached to it like this?
Okay, product rule x squared y squared. The first term is x squared, and then I'm gonna do a derivative of it. Doing the derivative of the other junk, I got a dy dx. Now, the second part of the derivative, y squared stays the
Oh,
same,
it's the derivative of the x.
and then the derivative of x, I didn't get a dy dx, I got a dx.
So if you take the derivative of it, if you're taking the derivative of x, then it'd be dx over dx.
Anyone get a number yet? Okay, I got one answer. Did anyone get an answer, a number? Is it 0? Massimo, what'd you get? 3? Jasper? 3? Got a couple of 3s, got a 0. Anything else? Amir, you frustrated with it?
I got 2 root 2 over 4 plus root 2 over 8 divided by root 2 over 4.
Which might be correct, but sounds like some stuff simplifies and all that. Anton, how did you get your answer?
Well, I plugged in the root 2's into everything. So 2 times root 2 over 2 cubed is just 2 times 2 root 2 over 8.
Okay. So I cheated. The x and the y are exactly the same value. So before I even started, I'm like, there's no difference. I'm like, this is effectively, since x and y are the same value. Eitan was good with his math and did it without this cheat. It comes out to 3. This ends up being 3 halves divided by 1 half. Yeah, kind of, sort of.
Makes sense.
Yeah, I know. Good times.
Why did you put in 1 over root 2 instead of root 2 over 2? You plugged it in.
Make the numbers smaller. They're the same. And I like 1 over 2 better. But you can do whatever. But yeah, I cheated. So much faster this way.
Why is it in the original it's x squared y minus y, and then the bottom you like swapped it?
These two,
No, like at the bottom it's like x squared y, which would be like the x third at the bottom. But like you swapped it. It's not.
this one to this one.
Yeah.
Okay,
That's so much easier.
That's it, easier.
as written, like kind of normal.
It's weird.
Those of you who moved it to the right got all these negatives. And some people don't like the negatives, or maybe they moved it to the other direction. If they moved it to the other direction, if I multiply by -1 over -1, I get positive 2x cubed plus xy squared. And then this would have been a positive y and a negative whatever. And just usually we have the positive thing minus the other. So it's off, like, just showing you, if this was multiple choice, the AP exam would probably not have this as the multiple choice answer. They would probably have it with more of the positives. And the way to change your answer is to just multiply by -1 on the top and bottom. Okay. This is what it looks like. Did we answer all the questions? Find the equations of the tangent and normal lines, so no. But there's the slope. Fiona, what was the slope evaluated, that coordinate? 3. So Nick, what is the tangent line?
Y minus √2 over 2 equals 3 times x minus √2 over 2.
And I'm being a pain, I didn't write exactly what he said. Jamie, what's the normal line?
Y minus √2 over 2, or whatever, 2 equals A/3 times x minus 1 over 2.
So normal line, the only difference is negative reciprocal slope to get the perpendicular. And again, that's what it looks like. Ooh. You're unimpressed.
So,
Last year's seating chart. Let's see. Are we actually done today? Okay, now asking you to do double derivative. And we can use from the warm-up, we got dy dx already. Dy dx from the warm-up was -x over y. So using that, how do I do the double derivative? What am I starting with? Do I start with this to do the double derivative? The x squared plus y squared equals 25?
Yeah.
No?
Negative x
Find
over
the
y.
derivative of -x over y.
Fiona says, no, we are looking to find the derivative of that quotient. Yes, that's where you start.
Is,
Yes.
am I supposed to put derivative of x in the quotient rule?
Well, bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Yeah.
I don't know about that one. Like, past examples, you told me not to, do, it's confusing.
What's that, Gus?
Maybe not.
Okay,
Yes.
we're just following the rules. Bottom times, what's the derivative of the top?
-1.
-1. Minus the top, what's the derivative of the bottom?
The derivative bottom.
dy dx. That's the catch. Over the bottom squared.
It's 1. dy dx is 1.
No, dy dx is somewhere else written on this page. What is dy dx?
The derivative of y.
Look.
Negative x over y.
There you go.
Over y.
That's smart.
I'll pick it up.
Dude. Yeah, that's what I got.
Just to explode your brains. That's the double derivative.
Oh, okay, I don't.
Like, yeah, like what the heck? Where's the,
Okay, I think I get it.
so it's scrolled off the top, so you couldn't see this. But, all right, so as Amir said, oh, dy dx, it's not just one. It's the equation that we were given. And I can guarantee you there will be a question like this on the AP exam where they ask you to do the double derivative of an implicit function, and you needed to remember dy dx within it. What is dy dx? Well, it was the equation that Fiona said we needed to start with. So plugging in and cleaning up a little, I got this numerator. Factoring out a -1, where did 25 come from?
The bear's not.
It was a circle with that radius.
This is Pascal.
Yes, I know, voodoo, what?
What happened to the y? What are we gonna do with it?
This y here?
The y at the bottom.
Okay, so, you're right. This actually told us to evaluate.
Oh.
So now plugging in 3 for x, which I already got rid of x, 4 for the y,
-25 over.
16.
Yeah.
Yes,
Okay.
so that is the slope there.
Yes, why?
Actually,
Didn't simplify all that, would I still get the same answer?
Okay,
Actually, Miss Pascal.
Like, just for like,
hold on.
going sake.
4 cubed is 64.
Oh, no, I would.
Cubed, 64. So hang on. When they ask you to plug in, you can plug in right there.
Okay.
Like as soon as you get things that are all the numbers and, or all variables that you know numbers for, plug it in.
Okay.
Sydney?
How do you know to y over y?
Well, I don't like fractions and fractions, so I flex them by like, but again, this was asking you to evaluate and get a specific number. So I didn't have to be fancy and do this. But Amir, I wanted to show you guys this, because this was on the AP exam where they didn't say find it at this coordinate, they just said find the double derivative, and it was multiple choice, and
Okay.
that was not there.
Find the double
This
derivative.
was.
Okay.
I was like, that's mean, that's really mean, like rude.
Yeah.
Okay? Happiness and joy, like you really need to do the homework tonight. Like this takes practice. And this is it.